Hi, welcome to Mrs. Park's geometry class. So we are back on video lessoning by popular demand. So we're going to start with 1-6, two-dimensional figures. Okay. So why are we learning about this? So here you see a lot of um, shapes here, and these are called mosaics, and you've probably seen them at church windows before. And they're patterns or pictures creating small bits of colored glass or stone. They're usually set into a wall or floor and often made use of polygons. So identifying polygons. Most of the closed figures shown in the mosaic are polygons. So every little shape here that you see inside, they're called polygons. The term polygon is derived from a Greek word meaning many angles. Okay, so polygon came from the Greek word meaning many angles. Okay, so the concept is polygons. What it is a closed figure formed by a finite number of coplanar segments called sides, such that the sides that have a common endpoint are non-collinear. Remember, non-collinear means non means not, co means together, linear has the word line in it, so not together line, so they're not on the same line. Each side intersects exactly two other sides, but only at their endpoints. So that means each of them meet at one point, connecting each other. The vertex of each angle is a vertex of the polygon. So each of these points there is called a vertex. So a polygon is named by the letters of its vertices, written in order of consecutive vertices. So here, when you're going to name this polygon, you start with a vertex, okay, and then you're going to go in order. So here is polygon, it starts with G, G, H, J, K, L, M. So you can start with any vertex. So if you start with H, you can say polygon H, J, K, L, M, N, or you can go the other way, H, G, M, L, K, J. Okay. So just start with any vertex and you just go around in order. So here are some examples of polygons, okay, on the left side. And here on the right side are examples of non-polygons. Okay. So you see here, this one is not completed. This one is wavy. Okay. These have two polygons actually connecting. Okay, this one is extending, and any kind of waves or curves are not considered polygons. Polygons can be concave or convex. Suppose a line containing each side is drawn. If any of the lines containing any point in the interior of a polygon, then it is a concave. Otherwise, it is convex. So I like to think of concave as it's caving in, so inward. So anytime you have any inward angle like this, it's called a concave. And when you have outward angle, it's called convex. So no points of the lines are in the interior. So this is a concave. When you have something caving in and the vertex, the point is inside, interior, then it's called a concave. In general, a polygon is classified by its number of sides. The table lists some common names for various categories of polygon. A polygon with n sides is an n-gon. For example, a polygon with 15 sides is a 15-gon. So we have up to 12. There are certain names for each polygon with the number depending on how many sides it has. So 3 sides called a triangle, 4 sides quadrilateral, pentagon, hexagon, up to 12. And then from 12 on, we just say it's an n-gon. So if you have 13 sides, you will call it a 13-gon. An equilateral polygon is a polygon in which all sides are congruent. Okay, so equilateral sounds like equal, so it has congruent sides. Equiangular polygon is a polygon in which all angles are equal, congruent. Okay. A convex polygon that is both equilateral and equiangular is called a regular polygon. So when you have a polygon, all the sides are equal. Okay, those lines meaning the length and sides are equal. And then you have all the angles that are equal as well, then it is called a regular polygon. An irregular polygon is a polygon that is not regular. Name each polygon by its number of sides, then classify it as convex or concave, and regular or irregular. Okay, so here you have, it's caving in, so it's a concave. Okay, well, first thing, name each polygon by its number of sides. So you want to go back and look at the table that I just showed you. So count the sides: 1, 2, 3, 4, 5, 6. 6 sides. It's called a hexagon. Okay, so that's a hexagon. Let's just write it out. Well, it's right here. Hexagon. Okay. Two of the lines containing the sides are inward, so it's concave. And then is it regular or is it irregular? Well, you see all the sides are equal, but the angles are not equal, so it is a irregular. Okay, so those are the three main questions we're asking here. So for next one, count how many sides. So 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, octagon. Okay. There's no angles caving in, so it is a convex. All the lines sides are equal and all the angles are equal, so this is a regular octagon. Okay, so here's your turn numbers 1A through 1C. You can go back and look at the chart or the table that has the name of each polygon, depending on the sides. Use that. So there's three things you need to tell me. So name of each polygon, classify convex or concave, and if it's regular or irregular. So go ahead and pause the video and come back when you're done. Okay, welcome back. All right, so we're going to briefly cover perimeter, circumference, and area. Okay, and these are terms you've all heard before. Perimeter is when you have the length around. Okay, so we're going to add all the length around. So the perimeter of a polygon is the sum of the lengths of the sides of the polygon. Some shapes have special formulas for perimeter, but all are derived from the basic definition of perimeter. You will derive these formulas in chapter 11. The circumference of a circle is the distance around the circle. So the circumference of a circle is kind of like the perimeter of the circle. It's the length around the circle. An area of a figure is the number of square units needed to cover a surface. Typically, you would multiply to find the area. Review the formulas for the perimeter and area of three common polygons and circles given below. In this case, next slide. So here you have a triangle, a square, a rectangle, and a circle. And this is really a review that we've been doing throughout many years we've had math. You've probably seen this in elementary school. So triangle. P, the perimeter of a triangle is when you just add all the three sides. So B plus C plus D. The area of a triangle, 1/2 base times height. Okay. A square, the perimeter is when you add all four sides, so it would add up to 4s. The area of the square would be base times height, s times s, which is s squared. Rectangle, you have length and width. Okay, so when you add all four sides, you have two lengths and two widths that you would add up to get the perimeter. Area, you're going to multiply the length and width. Okay. For a circle here, remember the perimeter of a circle is called its circumference, and it's calculated by doing 2 pi r. Okay. R is half the diameter, the radius is half the diameter. So you can say 2 pi r, or we can just say 2 pi d, which is pi times the diameter. Area of the circle is pi r squared, pi times r squared. Okay, here are two examples of finding perimeter, circumference, and area of each figure. Okay, so for A, it looks like this is a rectangle. Perimeter is 2 times length plus 2 times width. So you're really adding 3.2 plus 3.2 plus 2.1 plus 2.1, and you get 10.6. So the area, you can multiply 3.2 times 2.1, and you get 6.72. And by all means, you're using calculator to do all these calculations. Okay. So for a circle, circumference is 2 pi r, and r is the radius, here is 3. So 2 times pi times 3, 18.85. Okay, area of a circle is pi r squared. So pi times 3 squared, and you get 28.3. Okay, so here's your turn, 2A through 2C. Okay, so go ahead and pause your video and go ahead and do those 3 problems. So you can look back in the textbook if you want to find those equations, or you can look back on this video as well. All right, here's a standardized text example. So the question is, Yolanda has 26 centimeters according to frame a photograph in her scrapbook. Which of these shapes would she use most or all of the cording and encloses the largest area? Okay, so we're looking for the biggest perimeter and area. Okay. A right triangle with each leg about 7 centimeters long. Okay, so a right triangle, okay, and you have 7, each of them are 7 centimeters long. So the perimeter would be 7 plus 7 plus 7, which is 21. Okay, and the area would be 7 times 7 divided by 2. Okay, so that would be 49 divided by 2. Let's do real quick calculations here. Okay, 24.5. Right. For B, circle with a radius of 4 centimeters. So it's a circle with a radius of 4. Okay, so perimeter is 2 pi r, and area will be pi r squared. Okay, so 2 pi r, 2 times 3.14, if you don't have a graphing calculator, times 4 with 25.12, and pi r squared, that'll be pi times 4 squared, which is 16, and you'll have 50.24. Okay. All right, for C, rectangle with 8 centimeters of length and 4.5 as width. Okay, so perimeter will be 8 plus 8 plus 4.5 plus 4.5, which will be 8 plus 8, 16, 4.5 plus 4.5, 9, and that will be 25. And for area, 8 times 4.5, and you get 36. All right. And for D, square with length of 6. So perimeter will be 4 times 6, 24. And for area, 6 times 6, 36. All right. So back to our question. Which of these shapes use most or all of the cording and enclose the largest area? So looking at this, largest area would be the circle here, and it has the largest perimeter as well. So our answer would be B, the circle with radius of 4. Okay, so here's your turn number 3. Go ahead and stop the video and go ahead and do number 3 and come back when you are done. Alright, so I realized the next skill that we're going to learn is going to be taking much longer than I had expected, and so I'm going to start the video at here. So we do the second part for another night's homework. So when you're done with number 3, make sure you put all your homework away, numbers 1 through 3, and hand it in for homework next day. So thanks for watching.